Imagine an artificial intelligence agent trying to learn the best way to navigate a complex environment, perhaps a robot learning to walk or a system playing a video game. How it learns from its experiences, especially the choices it makes, is crucial for its success. Two foundational algorithms in reinforcement learning, SARSA and Q-Learning, approach this learning process with a key distinction. The core policy difference between SARSA and Q-Learning lies in how they update their knowledge about the value of actions. SARSA, which stands for State Action Reward State Action, is an on-policy learning algorithm, meaning it learns the value of the policy that it is currently following. Q-Learning, on the other hand, is an off-policy learning algorithm, which means it learns the value of the optimal policy independently of the agent's actual actions. This fundamental difference impacts how each algorithm handles exploration versus exploitation. SARSA updates its Q values using the next action chosen by its *current policy, including any exploration. This makes SARSA a more conservative learner because it accounts for the agent's exploratory moves in its value updates, potentially leading it to find safer paths. Q-Learning, however, updates its Q values by assuming the agent will take the *optimal action in the next state, regardless of the action actually taken. This allows Q-Learning to learn the optimal policy even while the agent is still exploring suboptimal actions, making it potentially more aggressive in finding the absolute best path. To decide which algorithm might be better for a given task, consider the environment and your objectives. If you are in a situation where taking exploratory actions can have severe negative consequences, like training a self-driving car, SARSA's on-policy nature might be safer as it learns to account for the risk of exploration. If the environment is such that exploration carries little risk and finding the absolute optimal path is paramount, even if it means initially ignoring some safer but suboptimal strategies, then Q-Learning's off-policy approach could be more efficient. A useful way to conceptualize this is to think of SARSA as learning to drive by following all traffic rules, even if that means a longer route, while Q-Learning is like learning to drive by observing the fastest possible route an expert driver would take, even if your own driving is still cautious. SARSA directly models the behavior policy, whereas Q-Learning separates the behavior policy from the target policy. This allows Q-Learning to converge to the optimal policy faster in some cases, provided sufficient exploration, while SARSA's convergence is tied to the exploration strategy itself. Ultimately, choosing between SARSA and Q-Learning involves weighing the importance of immediate safety and adherence to a known path against the potential for discovering a more optimal but potentially riskier strategy. Understanding their distinct approaches to policy evaluation empowers you to select the right tool, ensuring your agent learns effectively within the specific constraints and goals of your artificial intelligence application.